Okay, it's 11:30. I'm going to get started. If I could come up with a talk where I could use this title, it would be much cooler. But unfortunately, this is the title I have. This is the Perl equivalent of that statement: code fast, die early, throw structured exceptions. My name is Johnny Anderson. This is the important part: throw structured exceptions. Oh, is that better? Thank you. I'm Johnny Anderson, GeneHack Online. I rep DCPM. Come on in. It's okay. The water's fine. So a little background, right? Classic Perl exception handling. You throw an exception with die, or carp croak, or confess, or whatever. There's more than one way to do it. It's Perl. And you catch exceptions with the eval. And then you handle the exception that you just caught by looking at $@. So this is what this looks like in code. Use strict, use warnings. You eval something that might fail, and if an exception gets thrown, do I have a pointer? I have a pointer. If an exception gets thrown, you handle it by looking at $@. There's a lot of problems with this. $@ can get clobbered. It can get clobbered by code that's not even yours, that you don't necessarily even know exists. It might be false. So when you do if $@, you might have an exception, but that test doesn't work. And if it's a string, if you're looking at the contents of that string, you're depending on duplicated information, which at some point is going to break, probably the least convenient time. So we have try-tiny. Everybody use try-tiny? Yeah, try-tiny rocks. It gives you sort of semi-modern Perl exceptions. It provides try, catch, and finally. It handles all of the details of properly dealing with the complexities around $@, so you don't have to worry about it. And it's lightweight, and it generally just works. It's awesome. The only sort of tricky part with try-tiny is because of the way the syntax works, you have to end your try-catch stuff with a semicolon, and if you forget this, the error that you get is really weird and will make you frown. So that's what the previous code, rewritten to use try-tiny, looks like this. You have a try block, and then a catch block. And if an exception gets thrown by this code, you'll end up down here. Semicolon, big red semicolon, very important. So that solves those three problems. You still have a problem, however, if you're throwing string exception that you're depending on duplicated information. So I keep saying duplicated information. Where's the duplicated information? It's right there, and it's right there. So there's some other part of your code where you're throwing an error, you're dying with a string, and then you're checking it with a regular expression. As soon as somebody fixes one of the strings in one of your die statements, like they correct the spelling or something like that, you've potentially broken exception handling in your application. And you can't even really easily tell where, because those two pieces of code might be in totally different places, widely separated. This is a problem. Even if you have tests for the code, you might say, oh, well, we have good tests. You don't really have test coverage on your exception classes, probably. Like, if you have the time to do that, can I work there? So what do? Well, die can also take a reference. You don't have to die with a string. You can die with a reference. So you can die with an object. So you can cram all sorts of stuff in an object and then die with it, which is awesome. That means that you can then catch it and handle it in a structured fashion. It's a lot less brittle than string comparison. So Dave Rolski has this great module called Exception Class that lets you set up exception hierarchies, very nice syntax. So you just use it, and then you have this this is yanked straight out of the documentation, set up your exception hierarchy. You can have inheritance. So yet another exception is another exception. You have descriptions. You can have fields where you can shove stuff into attribute slots. Awesome. And then you use it like this. You have a try-ish thing where you eval something, and you just call the throw class method on your exception class, and then you use exception class caught to see if you caught something and what it is, and then you handle it. This works really good. It's got a nice declarative syntax. I love the syntax. It's possible to declare very detailed or very simple exception class hierarchies very simply and very quickly, and it's all in one place, and you can see it. And you can set up aliases so that it's easier to throw an exception. You don't have to do long throw. You can just say throw. It does have some cons. It predates TryTiny, and it doesn't really play nicely with TryTiny. And it's based on CDI, not Moose. And that's not necessarily a problem, but generally speaking, I find at this point, if I'm writing something that's big enough that I want to have an exception hierarchy, I'm probably already using Moose. So it seems kind of silly to use two object-y things. So Rick, everybody say hi to Rick.
Hi,
Rick has a really nice Moose role called Throwable that I like a lot. That's basically class exception with all of the stuff that was duplicated in Moose in terms of generating classes and all that stuff stripped out. And you just use Moose for that, and it ends up being like 20 lines of Throwable code. So it's a role. So you're using Moose, and you say with Throwable, and then you just make a normal Moose class. You set up your exception hierarchy as just a series of Moose classes. Throwable gives you the throw method. And you just have your attribute slots just like normal. It's just Moose. Throwable Pros. It's implemented as a Moose role. So really my take-home message here is it's just Moose with just the throw stuff. So you get all the normal Moose stuff that you're already using and loving and just the throw method. And it comes with a grab bag of sort of mix and match stuff that you can add on that's stuff that you generally want around exceptions, stack traces, a very nice printf-ish format thing so that you can generate a nice message out of your error. I'm talking really fast. Cons. I haven't actually found any cons yet. It mostly just works. That doesn't mean there aren't any. I just might not have run across them yet. So basically, take-home message, if you're using Moose, use Throwable for your exceptions. It's great. It's awesome. In general, some error handling patterns and anti-patterns, stuff I've seen particularly at work, but other places, you should use exceptions instead of error flags. Let's get rid of the error flags. You should throw exceptions as early as possible. There's nothing I like more than seeing like a couple 100-line method where halfway through an exception is thrown because something didn't get passed in right. Like, if you're going to do that, do it at the beginning. Don't catch exceptions and then rethrow them for no reason. Like, if you catch it, it's your responsibility to handle it. If you're not going to handle it, just let it propagate. That's the point. And particularly if you're doing web application level stuff, generally the pattern that you're going to have is your business logic is going to throw an exception. The web app needs to handle the exception. So let's talk about each one of these a little bit more. So this very tiny bit of code has been somewhat anonymized to hide the guilty, is a catalyst action. So even if you don't know what that is, basically you would hit a URL on a web app and this code would run. So we're going to get this huge session object, and then we're going to validate our request parameters or go to the error method if the stuff didn't validate. And then we're going to call a method in the business logic model. We're going to pass in the session, and then we're going to check. Was there an error? If there was an error, we set a flag in the session object, and so we check. And repeat this like 27 times. Call a method, check the error flag. Call a method, check the error flag. It's really annoying. Don't do this. Okay, don't. Like, I'll do it for you. I'll do it for you later. If you forget just one time to check the error flag after you call a method, basically what's going to happen is and there's a problem in that method, the next check will get it. That's going to be after the method that didn't have a problem, right? You may spend a whole lot of time trying to figure out why the wrong method is broken. Not that I did that. You're passing around this session variable, which, by the way, has a lot of other stuff in it, but all you're doing is passing it around so that there's a place to hang that flag, which is stupid. And the error action that you're directing to doesn't actually get past the error, right? You just go to an error. You don't actually provide any information about what the error was or how to recover. So the error method then has to try to figure that stuff out, which doesn't work that well. If you use exceptions instead of error flags, that code ends up looking like this. You have a nice try block and a catch block. And if any of these things go wrong, they throw an exception, you end up down in the catch block, and then you pass that exception to your error method so that it can look at this structured object, introspect on it, figure out what went wrong, possibly recover. Throw exceptions as early as possible. Sort of talked about this already. The quicker you can die, right? Code fast, die early. The quicker you can die, the better, because it reduces the amount of code that might contain the reason why the exception is getting thrown. Don't catch exceptions, except to handle them. So most of the time, your business logic code will be throwing the exceptions. Business logic code probably not catching exceptions. If you do catch it, you should be trying to fix the problem. I've seen a very sort of virulent anti-pattern where an exception gets caught only to munge the message and then rethrown, which is really annoying. Don't do that. So for the reading, yeah, way too short. Sorry, guys. So Rick has a couple of very nice articles about Throwable X, and Chromatic has a very nice article on structured exceptions in general. Recommend people read those. They're good. Thanks. Questions? Lots of them. I just don't like it. Well, but if you're adding useful information, like if you're doing something conditional, when you catch it, like if you catch it and you're looking at it and potentially trying to recover from it or handle it, that's not just rethrowing it. I'm talking about things where an exception would be thrown, it would be caught, a constant string would be tacked onto the front of it, and it would be rethrown. Well, that's stupid. Just throw the right damn thing in the first place and let it propagate. If you're actually touching it and looking at it and trying to figure out what to do with it, that's not what I'm talking about. Yeah. Okay. That's the level. Okay, so this is why you should use Throwable, because that's the level of stuff he's worrying about. Everything else works. Yeah. That should also be another probably don't do this.
You throw exceptions when it's very rare, and as we've pointed out, you don't have time to test your exceptions. So if you type the class name, you're screwed. But I can solve that, and I'll tell everybody how in my talk tomorrow. Exception.
I can tell you before we do that, otherwise I don't like it gets your thought. We use a library called LooseX Class Compositor, which you get a bunch of roles and go through a class, so you don't actually run. I don't run classes anymore. It's like so. And so we make a curried version of that object where you say throw, and then you name whatever class, whatever roles you want the exception to have, and it generally deals with this problem. Most of the time, you don't need any roles. It's like I'm just throwing an error, and it is compiled, so the runtime is determined it's going to work. But it's not perfect, but it's okay.
I'll explain what I did to get around that.
And what time is your talk?
Just after lunch in 101.
Any more questions? Yep, somebody in the back.
Yeah.
So why doesn't exception class work with try-tiny? Basically, let me go back to the code. It's not that it doesn't work with try-tiny. It's just sort of not compatible. Right. So you're doing the eval, right? This is your try block. The exception is not in the right spot, basically. You have to check, you have to call the caught method and see if you get something back. So I'm sure you could make this work with try-tiny. It's just, this is the recommended usage pattern. Because again, it predates try-tiny. Yeah. Did somebody else want to handle that? Because try-catch has a longer history. It does sort of more magic stuff. Try-tiny is, I think, just smaller and nicer.
Try-catch has a ridiculous amount of dependencies, which means it's great for using your own stack and terrible for depending on if you want to sort of see how much.
So big dependency stack with try-catch. That was sort of the evil that I was talking about.
I don't think double declare is exactly evil.
It's just misunderstood. Yeah. I would say, like, if you're not already using Moose and you don't need Moose, don't add Moose just to get throwable. I mean, you can definitely go overboard, right? Where you have, like, you know, class exception, : Tuesday, : phase of the moon, where you get overly specific. Most of the time, what you need is just enough information so that when you're looking at the stack trace, you can get back to where it came from. I think writing a lot of code that tries to do a lot of exception recovery is a very twisty rabbit hole to go down. It's oftentimes better to just blow up noisily.
So you're not recommending reflow with, blob of text appended, but if you've looked at any stack trace where you're using this, I anyway want some help sorting through what's crap and what's something I really need to worry about in the stack trace with this. And prepending something and rethrowing is a way to do that. It's maybe not the best way, but it's a way.
So you could, one of the things you can do for things like exception class, which is kind of using stack develop stack trace underneath the hood, is you can tell it what not to list in your stack trace. That can help. I'm not sure what program you use, but I think it needs to tell that.
But that's slow. It's got to be pro. Throwable actually already uses this technique in the varieties piece of code in Throwable. Because when you're building this object, you construct a Moose object, there's like this big stack already just in your construction. And so when you try building a stack trace, you got this extra like 7 or 8 frames. And originally I forget what it was, but whatever it was, I was ashamed of it, the high piece. And Florian Ragwitz came in and created the filter system to allow you to filter out stack frames, which was really useful. And so you can use that yourself to filter out the new stack frames. My experience has been that you're way better off leaving all the stack frames in there and letting the skim for the classes you're going to be care about, because then you find out, wait, there wasn't supposed to be a method modifier there, and it's. But you can do it. There's.
Well, the other thing to keep in mind with filtering is that you may be the person looking at the stack trace now, but when the stack trace happens for real, it might be somebody else, and they might not appreciate your filter, right? Your unimportant information may be their critical information. Yes, sir. I can see that the don't rethrow things after munging them is a religious position. Well, it's a religious position that I have the right position on, and these other people are wrong. But shh. All right, thank you. Oh, one more. Well, they have types, right? They're like, if you set up your Moose hierarchy, your type is just your package name, and then you just check the ISA, or if you want to be like all cool and rollsy, you can check on capabilities. You can introspect on, for example, attributes or methods that are implemented in the exception class. So you can basically duck type exception handling. Try catch does that, yeah. Try catch will let you have, I think it has like conditional catch blocks. Right. Try catch. Yes. Yeah, I mean, try catch is basically just a more complicated version of try tiny. It's a different way. There's more than one way to do it. It's a different way of getting try catch sugar. Yes. What do you think, Jesse? All right, thanks.